Okay, so in this video we are going to go through the solution for the question 9 that's on the sample paper for the A-level maths syllabus on Edexcel. It is question 9 and it's a static question. It's on the paper 3 for the A-level syllabus. So here we go. We've got a uniform ladder AB of length 2A and weight W. Has its ends on a rough horizontal plane. The coefficient of friction between the ladder and the ground is 1/4. The end B of the ladder is resting against a smooth vertical wall, as shown in figure 1. A builder of weight 7W stands on top of the ladder. To stop the ladder from slipping, the builder's assistant applies a horizontal force of magnitude P to the ladder at A towards the wall. The force acts in a direction which is perpendicular to the wall. The ladder rests in equilibrium in a vertical plane perpendicular to the wall that makes an angle alpha with the horizontal, where tan alpha is 5/2. Now, something we need to be aware of here. So we've got this ladder, it's resting against a wall. We just need to be aware of how friction is acting on the ladder, which we're going to go through now. So the first thing we're going to do is to mark on the forces. So we need to make sure the force diagram is correct. So we're going to have a reaction force here. Okay, and we're also going to have the force of the weight of the ladder acts at its center of mass here. We're going to have the builder, whose weight is 7W here. We're also going to have the normal reaction of the wall, which is here. The ladder wants to slip down, so the friction would be acting in this direction. And we're also going to have another force there. I'm just going to draw it parallel, it's actually at the same point. And that's the force P. So let's mark on our values for each of the forces. See, we don't know the normal reaction, so that's an N. From the wall, and from the floor is, I'm going to call it R. And then we've got W here for the weight of the ladder. We've got the friction, which I'll just mark in here. Let's call it FR. And P is the force that keeps it upright. Okay, so we've done our force diagram. Forces are all marked on the ladder. First question is asking us, show part A, show that the reaction of the wall on the ladder at B has a magnitude 3W. In other words, we're going to be finding out what is N. Okay. So there are several parts to this, but generally with these sorts of questions with statics, you've got to consider this. If it's in equilibrium, up force equals down force, right force equals left force, and anti-clockwise forces equal anti-clockwise forces, and so on. Let's start by resolving vertically. Resolve vertically. The up force is the reaction, and the downward forces are the weight of the ladder and the builder. So that gives us a reaction force of 8W. Now resolving horizontally, we've got our force P, the builder's assistant that applies a force of P to the ladder, acting in the right direction, and the friction, as we've already alluded to, is going to the right because the ladder wants to slip down, and the assistant is only just applying enough force to prevent the ladder from slipping downwards, and the left force is the N. So let's substitute in mu r for friction. And we've been given that the coefficient of friction is 1/4. R we found already to be 8W. 8W is N. So we have an equation here for N. N is P plus 2W. But again, we still don't know what P is, because we've got an unknown N. So since we've done the right forces and left forces, up forces, down forces, the only thing left for us to do is to take moments. So if we take moments about A, since we don't know anything about P at that point A, so we won't have to use it there. So taking moments about A, we're going to have clockwise moments. That is the force of the weight of the ladder in the direction that's perpendicular to the ladder. So I'll just mark it on here in a slightly different colour so we can see what's going on here. So we're actually using that force there, resolving perpendicular to the ladder. We're going to have to do the same with the 7W force there, and also with the reaction of the wall up there. So at least we can see what's going on there. So we're going to times that by A, the distance. So it's force times distance, plus the force of the builder, which is 7W. So resolving that perpendicular to the ladder will give us 7W cos alpha. That's actually alpha in there. Okay. Times 2A, because that's the distance, equals n sine alpha. It's the anti-clockwise moment, since alpha would be that angle in there. So this pink arrow here is represented by n sine alpha, and the distance is 2A. Okay, so the rest of this part is just going to be algebra. So you can, with this question, work out from tan alpha what cos alpha and sine alpha are, but we could be quite clever here and divide everything by cos alpha, which would give us a tan alpha on the right hand side. So let's do that. And we can also cancel the A's. So we can collect those terms on the left hand side. 15W equals, well, we've got 2n sine alpha, so that's actually 2n, and sine over cos is tan. So this bit being the tan alpha, which we know is 5/2, times 5/2. 2's will cancel. Gives us 5n. It's 15W. So n is 3W. So that's the first part done. Okay. Okay, so to part B then. Find in terms of W the range of possible values of P for which the ladder remains in equilibrium. What do they mean by this? Well, P could vary. So we worked out in the previous part of the question what the normal reaction was, 3W. So we know that that force there is 3W. But when the assistant is forcing on the ladder we've assumed for the moment is a minimum amount of P, if you like, to prevent the ladder from slipping. So friction is acting in the right direction. But the assistant could be pushing to a degree where the ladder would want to slip forwards, like the assistant. put a lot of force on the foot of the ladder. So what we're going to do now is we're going to consider both of those scenarios. First, where the assistant would, presumably under a normal circumstance, apply a minimum force. So, resolving horizontally, let's call this P min. P min plus the friction is going to equal your force of your reaction at the wall, which was 3W up here. So these are the only horizontal forces that we have. Okay. Okay, so P min plus mu r, which is mu r, we found to be 8W. We'll just put that in there for now, and then we'll substitute. So P min plus a quarter times 8W equals 3W. So that's 2W, that's 3W. So that should just give us P min plus 2W, 3W. That means that the minimum force of P is going to be W. Now, we're going to resolve again horizontally, but this time the friction is going to be acting in the opposite direction. So, for all intents and purposes, I'm going to put friction on this foot ladder here. I'm just going to call that FR. So it's either going left or right. So P is obviously in the right direction, but it's a maximum force now. So P is the only force acting right now. So that's the maximum force P would be making before the ladder starts moving, or it could actually be moving, at constant speed. But that's neither here nor there. We're just going to assume it's about to start moving. So friction plus 3W. So you've got 3W, you've got your friction, you've got your P. We already worked out the friction up here anyway. It's done it for the third time, so we did it in part A as well. So that's 2W, that's 3W. So P max is 5W. So P, range of values of P are from W up to 5W. That's part B done. Okay, so for the final part, C, often in practice the builder's assistant will simply stand on the bottom of the ladder, explain briefly how this helps the ladder from slipping. So if the assistant was going to stand on the ladder, that means that the reaction would increase. The reaction would go up. Okay, so reaction increases. How does that affect anything else? Well, when we were resolving horizontally, we have friction and the normal reaction to the wall. So an increase in R would, friction, which is mu R, would also increase. So by friction increasing, that would help the ladder from slipping. I hope you found this video helpful. Do check out my other videos. If you have any questions, please make any comments below and I'll try to get back to you as soon as I can. Thank you.